Okay, so we talked about making a dot plot. Now we're going to get into histograms. Now both of these show frequency. Okay, it's just two different ways of displaying them. So a histogram is a bar style data display. It shows frequency measured over intervals. Now those intervals are a range of values. Okay, why do we need intervals? Well, because usually when we're using a histogram, it's because we have a larger set of data. So when are histograms primarily used? Large set of data. Okay, so if you look at our example, it says exam scores. And we have exam scores, all right, top score of 100 and then lowest score of, yep, looks like 62. So, I mean, that's almost a range of 40. You would literally have to list 62, 63, 64. You would have to list all of them up to 100 if you are using a dot plot because it's on a number line. You're not allowed to skip numbers. Okay? Whereas if you're using a histogram, we can break them up into equal intervals. So when you go to set up a histogram, must-haves. Must have a title. You must make sure you're labeling both axes. And then the biggest thing, and usually what's the most difficult, coming up with intervals. Like, what do you want to number by? So when we're looking at the exam scores, again, we have a max of 100 and a minimum of 62. So thinking about what do we want to number by? Usually I want to try and have between 5 and 6 bars to look at. 4 sometimes work, but sometimes it chunks our data too much, so it's hard to see the shape. Like how we talked about whether something's symmetrical or skewed. If you're combining too much of your data, then you won't be able to see that. So 5 or 6 is what I usually go for. All right, so let's see. What if we number by tens? So I'll pick nice numbers. So I'm going to start at 60. So think about it. If we're numbering by tens, that's 62, 69. If you don't believe me, count on your fingers. 60, 61, 62, 63. Yep, that gives you 10. I don't know why that always throws people. So how many are there from 60 to 69? All right, so 1, 2, is that it? All right, so I only have 2 from 60 to 69. We're still setting up a frequency table just like we did with the dot plots. Again, because they both show frequency. All right, so my next interval is going to be 70 to 79. So 1, 2, 3, 4, 5. Okay, so go ahead and continue this and fill in the rest. Okay, so I've got my frequency table all filled in. And I just want to double check that I got everything. So 1, 2, 3, 4, 5, 6, 7, 8, 12, 13, 14, 15, 16, 2, 7, 8, 9, 10, 16. Okay, so everybody is accounted for. All right, so when we go to set up our histogram, again, what's our title? Well, what are we talking about? Exam scores. Now, what is our x-axis? What is this? 60 to 69, 70 to 79. Again, that's our scores. And y-axis, frequency. You could even, if you want to be fancier than frequency, you could say number of scores. Okay, because it'll be the number within that category. All right, so when we go to set it up, 60 to 69, so I'm going to start at 60, and my next one will pick up at 70. Now, what do we see? The highest is 5. 1, 2, 3, 4, 5. I can almost skip lines. 2, 4, 6, 8, 10. Oh, sweet. I'm going to do that so it's more spread out. So I'm going to go ahead and label my Y's. Okay, so from 60 to 69, we had 2 people. And then we pick up at 70. From 70 to 79, we had 5. And then I pick up at 80. So when you're reading these, within this bar, it's 60 to 69. 70 does not start until the next bar. 80 won't start until the next bar. That is something where people get a little confused sometimes. All right, so from 80 to 89, we got 3 people. And then from 90 to 99, 4 people. Whoa. And then 100, 2 people. Okay, so differences between a histogram and a bar graph. This is a histogram. Everything is touching. No, you don't shade in the bars. On a bar graph, there'll be a space in between here. Now, bar graphs are usually used when we have categorical data. So that was like when we had, I don't know, favorite brand of shoe. So we might have Nike, Reebok, Adidas. You got me. So each of those categories would have their own bar. And again, there would be a space in between. A histogram is used for large sets of data, and it's used for continuous, or the measurable data. So height, if we're depending on how we're measuring, like we can get pretty darn precise there. So that's why it's necessary to use an interval, because you could have quite a few things going on between, let's see, or if you're measuring distance, are we measuring in feet, inches, centimeters? I mean, you can get really precise. So let's look, we're given some examples, and it asks us to represent the following. Oh, we did that. So we're just going to answer these. Determine the sets of data where it would be better to use a histogram instead of a dot plot. So again, we want to think about who has the larger set of data. So average daily temperatures for Albany, New York over a year. Now let's think about temperatures in New York over a year. Well, it gets really cold in New York, and it also gets pretty warm in New York, so that's a pretty wide spread of data. I'm going to say, yeah, that's definitely better for a histogram. Now, daily temperatures over a month, they are not like Florida where it's 50 one day and 85 the next. So I think daily temperatures is probably going to be better suited for a dot plot. It's not a wide range of data. The results of rolling 2 dice over and over. Okay, well, let's think about what could the results of rolling 2 dice be. Well, the smallest would be a 1 and a 1, so that would give us a 2. And then the largest, a 6 and a 6 to 12. So 2 to 12, that's only 10 possibilities. I think that's probably better for a dot plot because it's not at that wide range. Height of high school football players. Well, the first thing I see here is height. It's a measurement. So a measurement is definitely perfect for a histogram. Finishing times of 125 randomly selected athletes for a 100-meter race. Okay. What jumps out at you? I'm imagining some of you are like, well, it's 125. That's a lot of data. That's definitely a histogram. That's true. However, it's also time, again, which is a measurement. think about it, for anybody who ran track, they are clocking you in not just seconds, but I think it's out to the nearest hundredth or thousandth. So yeah, that's definitely going to be used a histogram. You're going to want to have an interval of maybe, 0.5, probably smaller than that. So maybe a quarter of a second. I have no idea, because you got to be really precise. So you're going to have some really tight intervals to see where people fall. So if we're given a histogram, so we have this, it says the size of each house on Prince Street. So first thing when I look at this, I'm like, this data is a little bit skewed. Like just by looking at it, I see that. Because I look and I'm like, all right, well, the bulk of my data is in here and I've got a little bit. So I would say it's slightly skewed right. There's a little bit of extra information off to the right that doesn't quite fit, but not bad. So slightly skewed right, but it's pretty symmetrical. Oops, I just answered something. Shape of the distribution. So slightly skewed right, I would say. All right, let's go in order. How many houses are on Prince Street? Okay, well, the size of each house, that's my x-axis, and then the number of houses that are that size. So how many houses? Well, how many houses are between 50 and 99 square meters? 4. And then I've got 7, 9, 4, and we got one big house. All right, so how many houses are on Prince Street? Just add them all up. 25. Now, how many houses are 150 square meters or larger? So let's find our 150, where that starts. So 150 or larger. So greater than 150, that's going to be 9 plus 4 plus 1. So 14 houses. So analyzing, it's all about knowing how to read your graph. So just make sure you're paying attention to, am I supposed to be looking at the X, the Y, or both? All right, how many more houses are between 150 and 200 than 200 and 250? Oh, I used the wrong color. All right, so between 150 and 200, so 9. So how many more houses? So 9 minus 200 and 250? 4. So 5 houses. So when you're analyzing this data, I know compared to some of the stuff, this probably you guys are like, oh, this is sweet. This is easy breezy. Awesome. I hope you feel that way. However, sometimes the questions will be phrased a little bit tricky. So make sure, don't just like go to town and start doing whatever you think they want you to do. Make sure you reread the problem so that you're actually answering what they want you to. All right. Well, good luck, and just hit me up on my office hours if you guys need any help. Have an awesome day.